SES is one of our more important clients. Many of you have probably used Astra satellites to receive your TV signals, so that's SES. The European Space Agency probably needs no introduction. We also work with Airbus, whom you know from manufacturing of aircraft. It's a lot less known that they make more money from space technology than they do from aircraft manufacturing. And UNHCR, the UN Relief Agency, as I said, among others. But back to the topic, back to the subject. If you're like most developers, you know this, right? This probably seems familiar. A lot of us have produced our fair share of data entry forms, reports, read pages and pages of logs looking for what went wrong, troubleshooting locking errors, making sure that your web page renders the same way in this browser and the other browser and this version of the other browser and so on. And this is all fine and well. This is our bread and butter. It provides value for customers. It's good to feel valuable. It's good to do something worthwhile, but it's not the most exciting work that we do, is it? Sometimes, though, you have work turns into play, and you get something that's kind of too good to be true, a task like that. And the last time this happened to me was on this project, on Blink, where Blink is a system, a software solution that we develop that's aimed to replace legacy hardware solutions to receive satellite scientific data on the ground. And what it does is, so there's a satellite in orbit. It's flying really fast, maybe 8 or 9 kilometers a second, and it spins around the globe, does a revolution every 90 minutes, and records data, records, and then appears on the horizon above a ground station with an antenna, and dumps all that data in the 15 minutes that it's visible in the sky. And then behind the antenna, which receives and amplifies the signal, there's a demodulator, which interprets the data, so gets a demodulated stream. And this demodulated stream is the input into our system, into Blink. And then Blink looks for frames, assembles packets, detects anomalies, separates valid and invalid data, stores everything to disk, and forwards it to downstream applications, downstream systems, which then do image analysis, distribution, and so on and so on. So that's where we are with the system. And our problem was that we didn't have test data, not enough anyway, to support development. And there are two key reasons. One is that we've had to sign a lot of NDAs, and our partners as well, so not everything that could be used can be delivered to us, and we can't use it in every way that we'd like. And another problem is that we simply don't get enough of it. So we get a bit here, a bit there, and that's just not enough. And so before I move on to how we've approached solving this problem, I have to give you a glimpse of, try and give you a feel of what it's like to work in this industry. Because we've worked on a number of missions which have a budget upwards of €500 million. And we've delivered systems which control arrays of 12 or 14 meter antennas under which there's an underground labyrinth of state-of-the-art equipment. So the general theme, the underlying theme is that these systems, so you can't build anything without spending years on it. You need large teams with lots of specialists, and it's terribly expensive. That's basically a short summary of the space industry. And so it took a little bit of an inspired moment to kind of snap out of it, to break the spell and come up with an idea. Why wouldn't we receive test data directly from a satellite? And the short and simple answer is because we have no idea how. We're software developers like you. What do we know about radio communications, telecommunications, about antennas, about... and so there's that, definitely. We've been exposed to it to a certain degree, but we're not specialists in this arena. But we had the right circumstances, a little bit of time, a few people available, and we said, let's give it a try anyway. Let's see what we can do. Let's play with it. And play we did. So the first thing we needed to do is find a suitable mission. And find one we did. This is Meteor M2, a Russian meteorological satellite launched from Baikonur in 2014. And it was interesting because it transmits data with the right protocol, the one we're interested in. And critically, it sends that data at a low enough bitrate that we can receive it with a primitive antenna. And when I say primitive, I really mean primitive. So this is our, we're proud to say, so our product, plastic plumbing pipe, coaxial cable cut to very precise dimensions for the specific frequencies that we wanted. This one is in our courtyard. We went crazy and built 3. One is in Velika Gorica and another one is in Luxembourg. And yeah, so we found a mission, so have an antenna, and now we need to feed the signal somewhere. So we went online and really, started spending like 20 euros on a device to digitize. So this is a software-defined radio, a very simple one. And what it does is it digitizes the analog signal. And so you have an antenna, you have this, it digitizes the signal, and then we need to demodulate it. And for this, we used a third-party solution called GNU Radio, which is a toolbox for digital signal processing. Anybody familiar with GNU Radio? One or two hands. Excellent tool. So we assembled a chain that does demodulation, whatever that is, and the output of this software demodulation chain is exactly the kind of input that we need in Blink. And so we prepared everything, connected everything, turned on, and then got nothing. And Niels Bohr famously said an expert is a person who made a huge number of mistakes in a very narrow field. And I guess we took him too seriously, because bad antenna design, bad connections, wrong demodulation, wrong frequency, wrong positioning of the antenna. We basically made all the mistakes that we could. But at some point, we fired the thing up again, and something beautiful happened. We got this. This was our first image recorded from the Meteor M2 satellite, and my desktop wallpaper for the next 6 months. And you can see, I'm not sure how much you recognize, but this is the west coast of Italy. There's a lot of cloud coverage. You can see Sicily over there, Corsica, a little bit of Provence, and it's damaged. It's a small picture, it's damaged, there's noise at the beginning, at the end, in the middle, but that is exactly what we wanted. This image is actually perfectly imperfect to me, because when you're working with state-of-the-art equipment in a lab testing satellite instruments, you can get arbitrarily clean signals, perfect data, and so on, but when you want to test a system, how far can you get with perfect data? What do you see? You don't see the system behaving in all the scenarios that it's supposed to work in. So this kind of noisy data with an actual atmosphere, with loss of sight, with rain, snow, all kinds of noise. Downtown Zagreb is a horrible place to put an antenna in. And so this is what we got. And we were very happy with. This was a pivotal moment. And so we thought, okay, what can we do now? And okay, we've done this once. Let's automate this, and automate it we did. And then we started getting 4 or 5 times a day images from this satellite, and that was great. And then we thought, okay, so how do we get added value from this data that we now collect? And we thought, let's open it up. Let's make it very visible. And so we built a gallery. And this is the gallery, and it's updated daily for anyone to see. And when you click on a picture, you get a larger picture, and you see how the satellite flew over the sky. But this is all eye candy, basically. What's important is the purple button to the right, which leads you to output of our industrial solution, the Blink, so the Blink system, which produces, among other things, very detailed, in-depth reports about what happened during transmission, the nominal information, warnings, errors, the timeline of events, so what happened throughout the acquisition as the satellite flew over. So, so that's the actual industrial product and a key selling point of the system. So at this point, we kind of wrapped it up, said, okay, so this is what we did. Let's take a step back and see what it is that we got out of this experiment. We set out to get test data for a system of ours. What were the actual results of the exercise? And it turns out a lot more than we had set out to get at the beginning. So for starters, we got a lot of knowledge. We were always on the margins of radio communications, digital signal processing, and so on and so on. We were in touch with this, but this pushed us way out of our comfort zone into another domain, and we really did get a lot more knowledge in this domain and are in a better position to offer products and services related to this domain. Second, we were kind of pushed ourselves to expand the product. We had to add new features to be able to carry out the experiment. Image extraction, decoding, so things like that. Third, we improved quality. During this experiment, we've encountered bugs and have managed to solve them before they reach clients. And along the way, we built a very nice presentation tool. And now, when we talk with new customers, potential customers, we basically always use the gallery as a starting point. And when they get to the report, that's when the coin drops. And then they realize what it is that we're offering and what kind of value it provides. Last but not least, we did get the data. So we did get the test data, and we're getting it day after day out of this kind of playful experiment within the project. And I could wrap up here and say, this is what we did, and I hope you've enjoyed it, and I look forward to seeing you after the talk in the halls and for drinks later today. But I'd like to, and I do, but I'd like to end on a personal kind of note and say, I've probably sent a few of you to sleep talking about frequencies and demodulation schemes and software demodulators and so on and so on. But this, to me, what I've talked about for the last 20 minutes is what I consider beautiful work. And it's going to sound corny, but whatever beautiful work means to you in whichever domain you're active in IT, in medicine, in transportation, in retail, in all kinds of domains, look for it and enjoy it. It's one of the best ways to remind ourselves why developing software is not a bad way to spend most of your day. Thank you.
Any questions, maybe? Anyone?
Hi.
Yes?
Very, very cool talk. Just a quick question to clarify. So the satellite that you're getting the data from, you have no official collaboration with the Russian space agency and so on. It's just you're piggybacking on something that already existed.
Yeah, so
okay.
we just looked at a catalog of active missions and filtered through them to find one that might be suitable. And the absolute and horrid lack of documentation for this particular mission was not helpful at all, but we managed to solve it anyway. So yeah, no formal collaboration with Ruscosmos.
All right, thank you.
Anyone else?
Here's a classic Corey question. What is your software stack?
What
is your software stack for the
software
Blink?
stack?
Yeah, for the Blink.
It's not much of a stack, actually. It's just a brick, and it's called the JVM. So the Blink is implemented as it's basically a Java library. It's built to be very, very fast and provide in-depth analytics. And a couple of years ago, I did a talk on how we managed to get very good results in terms of performance, in contrast to the usual theme 15 years ago, like Java is slow, Java is not, you can't use it for high performance computing. But it turns out it works quite well. So yeah, that's the software stack. There was a question somewhere over there.
Okay, thanks.
Yeah, it was regarding the satellite. So the signal is encrypted, or anybody can piggyback?
It's an open signal, so
It's open.
If it was encrypted, we wouldn't be looking at images.
Yeah, I was wondering. So
Yeah.
and the other satellites are also encrypted or opened.
It really depends on the mission. Some broadcast openly, some encrypt, some have the option to encrypt, so it really depends on the mission. But if you're interested in it like a radio amateur, yes, there are satellites that you can you probably won't build an antenna as advanced as ours, but still, it's possible to receive data.
So I'm interested in, were there any chance of complete failure when you were doing the expert thing of failing over and over again? Was failure even an option, or did you want to pursue this to the bitter end?
Absolutely. I mean,
So
failure.
my question is at what point do you cut off and say, okay, let's try another satellite, or let's just...
That's a very good. I mean, there is no magic bullet to this. There's no magic wand. You have to go by. It's like sprints. You say, I want to try this, and this, and then you do that. You don't think about should I do this or should I? We set out to do these certain steps, and if it gets us to the result, great. If not, then we'll see where we are and take it further. And then you stop and take a look where you're now. And then you evaluate your possibilities. So how likely do you feel it is that you're going to solve image extraction without documentation or decoding or whatever? And then say, okay, so what do we do? What do we do here? So failure was definitely a possibility. So it wouldn't have been catastrophic, but it would still hurt.
So hi. I'm here. So my question is, why is the satellite owner okay with those damaged photographs? Why isn't there sufficient error correction built into the protocol? Why isn't there resubmission of damaged photographs? I mean, are you just catching a weak signal, or?
So the satellite operator sends perfect images, more or less, for practical purposes. So the images themselves are okay when they're sent from the satellite. If we had a decent antenna, and if we didn't put it in a hole in one of the courtyards in downtown Zagreb, where it sees a little bit of the sky, then you could get much better, larger pictures with less errors and with fewer errors and so on. So it has nothing to do with the satellite operator. It has to do with receiving, with the receiving end and how you put it together.
We still have some time if someone has something.
Hi, my question is, what is the bitrate between the satellite and the ground station?
This satellite transmits using several streams. This is the slowest possible stream, and it's under 1 megabit, well under 1 megabit per second. So there are satellites and broadcasting at over a gigabit, a few gigabits per second as well, and which is when you get in touch with these, when you hear about these kinds of systems, it's really on an engineering level, it's really impressive what's possible and what people do. For example, I don't know, just to expand on the point, there's a system called European Data Relay System. So you have these satellites very close to the ground, which you can't frequently see, but you want to receive data quicker. You don't want to wait for the satellite to make a full revolution. So they put another satellite in geostationary orbit, 35,000 kilometers away. And then these two communicate via laser, and then the geostationary communicates with the ground. And when you think of the accuracy that they need, and so they use a 2-watt laser over 40,000 kilometers with both satellites moving at the same time, and they achieve almost 2 gigabits per second of transmission rate. So some really, really impressive technology. If you're off by 1,000th of a degree with the aiming device, you miss everything. So I'd like to meet those people and have lunch.